Ever stop to think about what's holding your desk or your kitchen cabinets together? Chances are it's a special kind of glue. Well, today we're going to dig into the science of how researchers took a pretty good recipe for that glue and made it absolutely fantastic.
Seriously, just look around you for a second. The plywood in your furniture, the particle board in your shelves, most of it is held together with a very specific kind of adhesive. It's this invisible workhorse of our modern world. But, that workhorse, it's got a secret weakness.
So the go-to adhesive for most of this stuff is called urea-formaldehyde resin. Let's just call it UF resin. Way easier. It's strong and it's cheap, which is awesome. But, and it's a big but, it has this one critical flaw. If it gets wet, it just starts to fall apart. And that's a huge problem for everything from kitchen counters to building materials.
Now, for years, chemists have had a fix for this, an ingredient called melamine. You add it to the mix, and boom, the glue becomes way more water-resistant. The catch? Well, melamine has its own issues. It's not cheap, and trying to dissolve it is like trying to mix sand into water. It just doesn't want to cooperate.
So to get around that, chemists came up with this really clever trick. Instead of forcing the melamine powder into the glue, they first mix it with acetic acid, which is basically the stuff that makes vinegar, well, vinegary. This little reaction creates a salt called melamine acetate, and that stuff dissolves in water like a dream. Problem solved, right? Well, almost.
And this is where our story really kicks off. A team of researchers looked at the standard recipe for making this melamine acetate and just had a hunch. They thought, you know what, I bet we can do this better. The whole process just seemed kind of clunky, and they suspected the old instructions weren't as good as they could be.
So they put on their lab coats and decided to really optimize this thing. They picked out 4 key variables in the recipe to see if they could tweak them to improve the final product. The main goal was to boost the yield, which is just the total amount of good stuff you get out at the end, while ideally saving some time and energy along the way.
These were their 4 main suspects. First, how long do you have to cook the mixture? Second, what's the perfect balance of ingredients? Third, how long do you really need to dry the final product? And last but not least, does the temperature have anything to do with how much you get?
All right, first up, reaction time. The old recipe said to stir the mix for about 10 minutes, so the team asked a pretty logical question. If we stir it for longer, do we get more of the final product?
And the answer was a big, fat no. Would you look at that? The graph tells the whole story. It doesn't matter if you stir for 1 minute or 30 minutes. The yield you get is almost exactly the same. Turns out, as soon as the melamine powder dissolves, the reaction happens almost instantly. All that extra stirring? Just a waste of electricity.
Okay, on to variable 2, the ingredient ratio. The thinking here seems pretty simple, right? Acetic acid is a key ingredient, so if you add more of it, you should get more of the final product. Makes sense.
But this is where things get kind of weird in a cool chemistry way. This graph shows that as you add more and more acid, the yield actually goes down. So what's happening? Well, too much acid makes the final product so soluble that it just wants to stay dissolved in the water. It doesn't want to form into the solid crystals that you need to collect. So yeah, more is definitely not better here.
All right, number 3. And this one's a big deal if you're actually trying to make this stuff at scale. The original recipe said you had to dry the final crystals in an oven for 72 hours. That's 3 whole days. In a factory, that's a massive amount of time, energy, and space.
And yeah, the data told a completely different story. After just 24 hours, the product was totally dry, done. In fact, if you kept drying it for 48 or 72 hours, the yield actually went down a little bit. It seems the product might have even started to break down from all that extra heat. So that's 2 days of wasted energy right there.
Okay, so far the big lesson has been do less. Less stirring, less acid, less drying, but the biggest discovery of all, the real aha moment, that came from the final test.
And here it is. The first 3 experiments were all about efficiency and cutting back. But this was about trying something totally new. The old recipe just had you let the mixture cool down to room temperature. But these researchers wondered, what if we actively chilled it? And as you can see from this graph, the effect was huge.
Let's just break that down. At room temperature, they were getting about a 28% yield. Not bad, but by cooling the solution down to 10 degrees Celsius, that's about the temp of a chilly basement, the yield shot up to nearly 38%. That is a massive jump in how much product you get, all from one super simple change.
So it turns out the secret ingredient wasn't more time, or more stirring, or more chemicals. It was just chilling out.
Literally, the single most effective change they made was just cooling the mixture down before they filtered it.
Okay, so after all that detective work, the researchers could basically rip up the old recipe and write a new one from scratch. And this one, it's way, way better.
So here it is, the new and improved recipe. Step 1. Just mix it until the powder disappears. Anything more is a waste of time. Step 2. Keep the ingredients perfectly balanced. Step 3, and this is the game changer. Chill the whole thing down to 10 degrees Celsius. And finally, step 4. Dry it for just 24 hours. That's it. So much simpler, so much more effective. And look, this is more than just a cool lab experiment. This stuff really matters in the real world. A more efficient process means less wasted material, and that saves money. Less time stirring and drying means less energy used, which is better for the planet and the bottom line. And what does it all lead to? Better, more reliable, more water-resistant wood products for all of us.
You know, it really gets you thinking, doesn't it? This was a chemical recipe that people had been using for years, but it just took one team with a fresh perspective to completely overhaul it. It just makes you wonder, how many other old recipes are out there in all kinds of industries just waiting for someone to come along and ask, hey, is there a better way to do this?